The problem with digging a tunnel in your back garden and putting it on YouTube is that someone like me can watch it. And who is me? I am a structural engineer. I have 18 years experience designing structures, not including the 4 years I spent at university getting my master's degree, and of those 18 years, 6 of which have been spent running my own structural engineering company. I like to think I know what I'm doing with things like this, and Mr. Colin Firth, I'm afraid you don't. And you have put all the evidence of this on YouTube for everyone to see, and that everyone includes me. Now, I'm not doubting Mr. Firth's capacity or ingenuity in developing cool projects and putting them on YouTube. He seems like a very capable, smart and likeable individual. This is not a personal attack on him. I genuinely couldn't care less about him, but I do care about the engineering. And he has presented this whole scheme as something that others should possibly take on themselves. Absolutely do not take on something like this yourself. There are a lot of structural things that you could potentially take on yourself with only limited knowledge, but underground structures, basements and tunnels and the like are not one of those things. So, to get started, I will let Mr. Firth explain his whole plan.
Oh, I've dreamt about doing this forever. Welcome to the Colin Firth channel, people. Subscribe, because you are going to go on a civil engineering fabrication ride of a lifetime. Now, regular viewers will know that I have an underground bunker in my back garden, and it is absolutely fantastic. It is like one of my most favourite things I have ever made. And ever since I've made it, I've always wanted a way of connecting it to this, my workshop, and my house. Now, of course, when I made the bunker, we quarried a hole up in the back garden, built a metal box, and covered it over. But I can't do that here, can I? Because the workshop and the house exist on top of it. So we've got to dig down and actually tunnel underneath it. Okay, this is the general setup. We have the bunker, we have the house, and we have the shed. Now, of course, this bit from here to here can be done above ground with a JCB. But from here along to here, no. We have to do it all by hand, digging it, going underground, but... Now, I'm actually going to do this in secret so as not to alarm the neighbourhood. And also, a secret project is way more fun. Scrape the surface off. This is solid rock. You whack in the pickaxe in and it's like boom, boom, boom. It is one big plate. So I think now we've actually hit the limestone seam.
This is the moment when I was first watching these videos when I thought, maybe he's got lucky. Maybe he's got lucky. I mean, tunnelling, luck, we're talking about geology here specifically. It's all relative. Just imagine that we're digging a tunnel through rock. Now, from a structural perspective, digging that, once you've got the tunnel in, once you've got the hole dug and the structure in, the structure isn't really going to be doing all that much because the rock is so solid, it's going to be doing such a good job. But equally, rock is a complete nightmare to tunnel through. You don't want to tunnel through it. You end up blasting stuff. I'll be honest, I don't have any experience with tunnelling. But I'd imagine that's the direction you go to if you're thinking of drilling through rock, because it's just impossible. If we go to the opposite scale, if we go through some sort of soft geology, then that would be much easier to drill the hole. But equally, there's a time delay between drilling the hole and being able to form the structure that makes the tunnel itself. And you don't want a soft soil that collapses between those two events. Just a little bit of local knowledge. I mean, London has such an extensive tube network, an underground network, simply because the geology underneath it, London clay, I mean, it's named London clay for a reason, is because it's so good. It's like the perfect geology for tunnelling in. So the whole tube network it exists in this very narrow geologic strata, which is just this London clay, because it's got decent, we can dig through it relatively easily, but we can also form a shell, a casing to that tunnel, and it gives us a bit of time delay between, it has a strength in that in between times. So in this portion of the video, I was thinking, well, you know, I have some understanding of the basic geology of the country. It's probably in a completely different location, but it's entirely possible that if he's digging this tunnel through rock, although it would be a complete nightmare for him, it's possible that the structural implications, he might get lucky, structurally speaking. He won't get lucky, from a hard work perspective, but he might get lucky, structurally speaking. And that was what I was thinking at this point.
I was kind of hoping it would be a bit deeper than this, because the bunker at the bottom, although we hit it there, the garden slopes down a bit, so I was hoping that the limestone would be a bit leveler, and then this would just be, well, whatever all this is, just nonsense on top of it. Here we go, corners all nice and square. Next thing I want to do is put some framework around the outside, to stop any collapses, but also we definitely know we're digging vertical, level, horizontal, everything, so we don't wander off and we end up with like some skew-width tunnel. Okay, welcome to the Colin First channel, people. So then, basically I'm digging a secret underground tunnel below my workshop.
Alright, let's address this issue of this tunnel being so-called secret. For a start, nobody cares. Like, the council, they're not going to come out to your building site just because they fancied it. They don't do surprise inspections anymore, at least not that I'm aware of. They're only going to turn up to site when you've invited them to site. Like, if you make a hollow noise, they're not just going to turn up and ask what you're doing. That's not. And the second thing, like your neighbours, they're not going to. Most people in England, like we keep ourselves to ourselves. If your neighbour's doing some excavation work or some noisy building work, you just assume that they've got the permission, all the right bits of paper. So you don't. So first up, the idea of keeping this thing secret to stop other people finding out about it. I think that's just completely ludicrous. The other reason, and probably the more important reason, is that by keeping it secret, you don't follow the standard established set of procedures that we in the building trade use to do projects like this. And that standard procedure is you go to an architect, they do you a set of plans, you submit those plans to the council, and they either give you permission to do what you've got on the plans or they don't. And if they don't, then you go back to the architect and you go around in circles until you arrive at a set of plans that everyone's happy with, including yourself and the council. And then once you've got plan permission, that's the moment that you approach builders and engineers. Me as an engineer, I'm not going to look at drawings. Well, I might have a conversation with an architect. An architect might phone me up and ask me to look at some drawings and give me their opinion on something that they're putting forwards for plan permission to see whether it's possible or not. But I won't put a pen to paper and start doing designs until it's got planning permission. Because if you don't have planning permission, I've done my designs and you have to change it, then I have to change my designs. And clients really don't like paying me twice for doing the same piece of work. And I don't like doing the same piece of work twice for one piece of the money. So we just wait until you've got planning permission, and we know that the plans aren't going to change from that moment. So from Colin Firth's perspective, the idea of keeping this secret and not going through the established channels means that he's not going through that procedure, and he's not got an engineer on board looking at these plans and telling him what he's doing right and what he's doing wrong. And he's kind of forced himself down this avenue where who's going to stand by his designs? When you have a set of designs done by an engineer, that engineer will come out and check that you're making it. The council will come out and check making it. Everyone will check that you're making it to that standard, that specification that engineer has spent a lot of time putting together. If you decide not to involve that engineer and you just decide to do it off the cuff and make it up as you go along, then at some point in the future you're going to need that engineer's approval for the work you've already done. And that engineer is not going to come on and just put that stuff on his insurance willy-nilly. He's not going to. The ultimate end game of all of this, of keeping it secret and not telling anyone about it, is that it makes you look completely untrustworthy. Whether that's through negligence or whether it's through hubris, it makes nobody in the construction trade trust what you're saying and what you're doing. Because if I went along on site and I said, "Have you done X, Y, or Z?" am I going to just trust the answer that he's going to give me? Because the likelihood is that X, Y, and Z haven't been done, and the idea of trying to retrofit X, Y, and Z to make it worthwhile, make this tunnel something structurally worthwhile, that's not going to be possible. So it's by keeping it secret, he's just locked out all of the important people that are going to guide him on this journey, doing this very, very difficult project. I just can't fathom it. And ultimately, I am in the construction trade, so I look at it in exactly the way that I've just explained to you. I see Mr. Colin Firth as an untrustworthy individual, regardless of what his moral character might actually be.
I am now 3.5 meters down. This is as deep as I need to go. The next part of this is we need to start going sideways. That way towards my underground bunker, and that way towards my house.
Okay, that is definitely not rock. That is some kind of rocky, clayey, gravelly mixture. Geologists, don't quote me. We can start to see the basic temporary frame here. Now this is just what he's constructing to prevent any cave-ins or collapses. You know, most of this stuff is mainly for his own protection, but it does come into play later on. And what I see when I look at this is a whole load of steel. I'm not really sure of the grade or the sizes or anything, but ultimately it's steel and it's underground and it's going to rust. It's going to rust like nobody's business. It's just... all of this is sacrificial. We've just got to assume that none of this is going to be here forever, that this is going to rust away in some 4 or 5 year period of time, because there's nothing here that's going to protect any of it. We've got steel here in direct contact with the rock. You know, the water is just going to find its way in there. It's just going to slowly eat away at all of this plate. All of this is sacrificial. None of this is permanent structure.
About 1.5 meters down, we're getting the systems down now. We know exactly what we're doing. Now I've brought the pump and the welder and everything down here now, so it's completely silent. That's all good, but we're learning. We've got different seams. We've got our clay seam at the top here. We've got our compressed clay and limestone seam here, loose limestone, and then big lumpy rock. Right, attack this side slightly differently. We've basically plasma cut it in half, our sheet, so they're only 200 deep. Slot that in first, just to hold that front edge up, because I remember on this side it all started to fall in too soon. So we've kind of stopped it from doing that on this one, and then we'll chimble a bit more, put the other half on, get a curvy bit, and then just continue as normal.
we're definitely starting to see the ingress of water here. There's rust and there's condensation on these steel plates. And let's be clear, this is still a very early days project. You know, a year, 5 years, 10 years down the line, these small patches of rust that you can see will be significantly worse. I mean, I would imagine that most of this steel plate that you can see will be gone. And that's why I said it was sacrificial. And although it is sacrificial, it is also not providing an impervious membrane to water. You know, unless you devise a specific membrane, like some kind of plastic or some kind of tanking that specifically prevents water from getting into a structure, it will find its way in. You know, it will eat through this steel plate, and then it will eat through whatever's next, and then it will eat through whatever's next after that until it makes itself known to you. There's just no ways about it. That's just what water does in underground structures. It's a continuous flow. It might just only be one drip, but it's perpetual. It's there forever. And this will just get worse. We can start to see the final form of the structure that Colin Firth is constructing here. And I really want to talk about it in some detail, but in order to do so, I'm going to have to really talk about an arch and how an arch works structurally, how we would design it, how we would go about that. Now, it's not essential to the story. So if you want to skip this kind of structural interlude, then I'll put a timestamp on the screen when all of it is over. But I think if you really want to understand what's going on here, I think you need to understand the structural principles at work. So let me move my camera over to my sketchbook and let me go through how an arch works. So why do we need an arch? At a very basic level, we need an arch because we need to span an opening. Now, in most cases, this is a doorway. But it can be more or less anything, to be honest. It just needs to span some kind of opening. That's the whole point. Now, nowadays, when we do these sorts of openings, doorways and stuff, we just use a horizontal member. We don't do arches anymore. And the reason is, at a very basic level, is because we have access to things which have a tensile capacity. You know, when you put something in bending, this puts tension into the bottom face. It causes this to sag, and back in the olden days, they didn't have access to anything that had any sort of tensile capacity, or at least they didn't have access to the kind of technology that we have nowadays, which would allow that tensile capacity to be joined to a masonry structure, a stonework, which is what they had back then. I mean, to be honest, you wouldn't do that nowadays. You can do it with concrete. That's another story which I'll get to in a moment. But the point is, the reason why arches exist is because we need to span an opening, and because we didn't have access to things that had a tensile capacity. And the reason is because an arch is a compressive structure. You put force on it like so, and it will react in pure compression. Now, there are a few caveats to that. To start with, this load on the arch needs to be a uniform distributed load. It can't be a single point load in the middle. If you have a single point load in the middle, then this thing will just want to kick out and it will buckle, like any other structure that's in compression. In order to keep that from buckling, we need this load, this heavy downwards load, to keep this arch from forming. So that's the first situation. The second situation is that this also causes an outwards thrust at the supports. As you push down, it wants to lever these two sides away from each other. And the only way to really get this to, there's two ways to get this to work. Firstly, we put this in a ginormous wall. So if this is in a ginormous wall, then that wall will take that shear and prevent this thrust from kind of pushing away from each other. Or if we don't have this wall, we would have some kind of tie that links these two together. But that would be a tension member, and we would go back to the original, what I was talking about from the beginning, which we don't really have access to A, tensile materials, or B, a mechanism for connecting that tensile material into masonry. So in most cases where you see these arches, there's a wall above it and there's a wall either side, and those walls are all confining that arch to make sure that that whole structure is in compression and that it can't move anywhere. For instance, you would not find a structure like this where you've got a wall above but no walls here. If you ever see this, you won't see. What you might see some sort of fancy buttress wall system. They tended to do this quite a lot in old churches and cathedrals and stuff, you know, because they didn't have access to a tie, and they wanted to keep this all in compression. So this is what they tended to do. They just tended to have these kind of ginormous buttress systems in masonry to kind of prevent this thing from spreading outwards. So that's what an arch exists to do. It exists to span an opening, and it does so by acting in compression. So how is this relevant to what Mr. Colin Firth is doing? So with that last picture that I showed you in mind, I'll bring it up just now so you can get it back into your memory. I'm going to draw a quick sketch of what I think he's constructing. So these dotted lines, they're indicating what I would term the steel mesh that he's got that's surrounding this whole cage, which is really, it's not reinforcement. Don't kid yourself, it's not reinforcement. It's what we would call chicken mesh in the construction trade, and it really is only used to, in a reinforced member like this, if we're not reinforcing it, it's only there to prevent the concrete from cracking and falling apart. It provides no real long-term strength. It's just there just to, well, from his purposes, it's there to prevent rock from getting in, and then it's something to have the concrete adhere to when he pours it. But the proportions that I wanted to get on here were that, from what I can see on the sketch, it looks like this dimension is a lot narrower than this dimension. You know, I've seen the video, I've watched a lot more than I've shown you, and I'm going to show you more. But from what I've seen, this dimension here looks like it's about 100 to 150 mil, which is 4 inches to 6 inches. And then it looks like we're about 200 mil here, so 8 inches. Now, I don't know whether his original intention was to have this consistent depth throughout, whether this arch was meant to be much higher, or at least not much higher, but 50 mil higher. And what's actually happened is that he's put this steel plate in, and the force of the soil above has caused that plate to move inwards, so that by the time he's got around to casting the concrete, he's lost 40, 50 mil because this whole plate is bent, and it's bent downwards. That's what it looks like to me. I don't think he intended for it to get narrower at the apex of this arch, but I think that's what he's achieved. Now, to go through the few things that I went through with the arch before, what we need is a whole load of vertical load. Now, this tunnel that he's digging, it's very, very shallow. I wouldn't be surprised if the soil above is maybe a metre to about 1,500. That's how much soil he's got on top of this arch. Now it's some load, but it's not a lot of load when we're talking about compression in a concrete structure. I'm not going to run any numbers, and to be honest, I haven't really run any, the design of an arch. I don't really know the mathematics of it. It's something that I only studied at university, and as I said, we don't do it anymore, so it's not something I really know. I'm not going to run the numbers. That would be a futile exercise anyway, because it would depend on a whole load of assumptions about what's going on. So, in my opinion, I don't think that's enough soil to cause enough compression to make this arch act without any bending. So I think there's going to, because this is not in enough compression, this is going to be acting in flex, and what's going to want to happen is we're going to need to develop a tensile force on the bottom of this steel plate. Now, There are available mechanisms in the British standards for combining concrete and steelwork in what we call a composite action, whereby the concrete is fixed to the top of steelwork, steel beams, and the two act in concert. So we get the tensile effects from the steelwork below, and we get the compression effects from the concrete above, and we join them with studs. And that's how we transfer the shear, because in order for these two things to act as one, we would need to join them together physically. Otherwise we're just relying on the friction between these two. So in order to rely on this steel plate to act as the tension member and the concrete to act as the compression member, which is a justifiable method, and it is relevant, we can prove it via the British standards with certain clauses attached, then what we would need to do is we'd need to weld stud work to the inside of these plates so that the concrete can adhere to that steel plate. And if we did that, then these two would act in unison with each other, and we would get that. This is what I was talking about when I was saying, back in the olden days, we didn't have access to stuff with tension, and we didn't have access to the method of fixing it. We didn't really have access to concrete, and that's why this method works. It doesn't work with stonework. This is just in steel. Now, that is the arch acting downwards. Now, if we took this tunnel in isolation, then the thrust force that we were getting here and here, if we took this tunnel on its own out in the universe, there was nothing to stop those thrust forces. The only thing in Mr. Colin Firth's universe which will stop those thrust forces is the soil. So as long as the soil is tight packed against the side of this concrete, and that concrete is tight packed against here, and there's no give here, then this thrust can't go anywhere because it's tight up against some soil. And that is not an irrelevant thing to consider. The problem is that it probably actually works against you, because what this is also a retaining structure. And we need to retain the forces that are coming from this soil in the other direction. And those forces are probably the dominant ones simply because we do not have enough compression from above. So when you have a retaining wall, let's remove these, we have a linear increase in force from the top. So the force will get bigger as we get deeper, like so. That will put a bending moment on the connection between whatever wall you've got and the foot. So we'll have a moment here, like so. And the only thing resisting that moment, because we don't have any steel plate here, the only thing resisting that moment in tension, because now we've got tension on this face, is this chicken wire mesh. And what it really needs is a whole cage of reinforcement. That's what it needs. And then also, the concrete needs to be a very, very specific mix, a reinforced concrete designated mix. And what we're going to see momentarily leads me to believe that that is absolutely not what we've got. So, what I'm trying to get across is that this thing is acting as an arch, and it's, in the real world, it's probably going to be okay because the lion's share of the structure is there. The problem is that as a structural engineer, I can't justify any of it. There are no formulas, there's no maths, there's no mechanisms for me to be able to put numbers to the structure that Colin Firth has put together to justify me or to justify to anybody else that the structure he has got is worthy of supporting these loads. And we are going to find out as we go on that these loads that I'm discussing here are trivial in comparison to what he's expecting this arch to do in the fullness of time. Anyway, let's get back to the video. there's just something about concrete in a wheelbarrow from a regular mixer truck that just sounds alarm bells to me. I don't know anything about what that concrete is specifically, but what it looks like to me is that that's the sort of concrete you would use for foundations to a house. You know, it's not any specific designated mix. It's got no admixtures. I'm just assuming that they just went and got the most basic bog standard of concrete that they could find. And in my mind, this is the sort of concrete, this is the sort of application where the concrete should be delivered by using a pump. Like with a much more viscous wet mix. I mean, you want all of this concrete to find its way into the corners and the holes. This looks like a very thick slurry. This is all opinion based on a picture and a few motion shots, but it just feels wrong to me. The idea of delivering this concrete via a mixer truck and a wheelbarrow, it just feels like the wrong way to go about it. I haven't been to enough sites when they've been pouring concrete to know. But that's what it looks like to me. It looks like this is foundation, just a normal foundation concrete. No special thought has been put into it. I mean, a few things to discuss about here. I mean, firstly, got rust on the ceiling. This is the rust that I was talking about earlier. That's just going to get worse. Secondly, we can definitely see that the depth of between the steel plates, the thickness between the steel plates that the concrete is supposedly going to be, is narrower at the apex than it is at the supports. I think is obvious. Thirdly, the idea that we can fill this thing with concrete and this concrete is just going to fill this thing up like it was water. I mean, I think it's just absurd to say the least. I mean, I don't think this is the only point where he's going to be filling it from. By my reckoning, there's a tube on the ceiling of this that you can see. I'll point it out. And I think that's going to be a point where he fills in concrete further down the line. But the idea that this thing is going to fill up with concrete and is going to be the perfect shape between these steel plates, I just think it's naive to say the least. In a construction environment, one of the most important things about reinforced concrete structures is being able to check the composition of the concrete that you've actually cast. You know, when you cast a column, just say for example, that's probably the similar sort of application that we're talking about here. You pour a column, you pour it from the top, and the whole kind of fills from the bottom upwards. What you generally tend to find at the bottom of these columns is that that's where the gravel accumulates. So when you put off the formwork, you find that it's all honeycombed and none of the concrete is set properly around this honeycomb. And then the rest of the column that further way up, you've got to deduce that it's probably got less of this aggregate in it than it probably needed it to have. So by having... It's so important that that formwork comes off and that we can check that the concrete is what it should be, because if it's not, then we can patch it up and repair it. When you encase a concrete wall, a structural piece of concrete between two pieces of steel such that you can't ever check whether it's made its way through, you can't put a vibrating poker. That's another thing that we do to prevent the formation of air pockets. You can't put, and it's another thing I don't see him doing either. You know, a vibrating poker just to move this stuff around. He's just using the end of a pole. I just think this whole concrete experience is just naive. It's no one's ever going to be able to check. No one's ever going to be able to prove it. It's always going to be an open question mark, and that's just the way that it is. And you know, let's just assume for a moment that this concrete doesn't fill all the way to the top, the apex of this top piece of steel. Then what you'll end up with is, firstly, a concrete apex which is less than the dimension I already had, which is probably already less than what it needed to be. Number two, that's going to be the perfect sort of flat surface for a pool of water to form in. And then over time, that pool of water is going to find a crack in this concrete, which is probably maybe 3 inches, 2 inches, 50, 75. You know, it's not going to be hugely thick. There's going to be cracks in it, and that water is going to find its way through, and it's going to start eating away at this bottom sheet of steel. I just can't see any other way. I mean, these are the sorts of shots which make me despair about this whole project, I'll be honest. But anyway, let's just carry on. There's more despair to be had.
Going to build another bit of box. I've been round the edges of these, grinded it all up, made it all nice and crisp. There's little bits of concrete. We're going to put some few more beams underneath the floor this time to kind of stabilise it a little bit while we build it. So we're going to come out another panel, another 1200, and then at the ends, instead of putting that like insulation stuff that we stuffed in the corners, we're going to do mesh all the way around there. So it acts like a little bit of reinforcement, and also it'll stop the concrete trying to blast all the blooming insulation forward and fill in the whole thing up with concrete. As you can see, there's a little bit of concrete which didn't quite flow right to the front there.
I'm going to let you use your imagination and come up with what you think the dimension is here between these two steel plates. It looks very, very thin for my liking. It looks very, very thin. It looks thinner than the dimensions I've discussed. You know, the 100, 150 mil, that looks a lot less for me. And the profile of the steel plate's not consistent. It's not a perfect arch. There are irregularities to it. It's just all, I mean, you come to your own conclusions about what this looks like. I can only go so far.
So we need to make sure that we get that bit completely full. Right, got concrete coming today. Now I've put some mesh all the way around the tunnel. This is to hold the weight of it back, to obviously stop it booming forward. We're going to put some wood as well up there just to stop all the slop coming through. And we'll see how we get on with that. Look at this, look. Knocked up a little tin chute.
Tapping down the walls to get a good distribution of concrete, good. Not a bad thing to do. Tapping down the walls at the end when you've finished pouring the concrete, which is what this sequence of shots seems to suggest, that all this concrete has been poured and now the walls are being tapped. That would just exacerbate the problem that I've been discussing, which is that the top portion of concrete, the concrete at the apex, whilst you're tapping, is pushing that concrete further down the sides. Like, you're making the situation worse. You're making the concrete at the top of the apex thinner. I mean, there's also a question as to how they calculated how much concrete they would need. Because if they calculated the amount of concrete they needed based on the perfect shape, and there was, you know, and they say calculated how much volume that was, and then they maybe added 10, 20%. What would have happened if they actually needed 30% or 40%? What happens if there was if the face of the rock was so irregular that you needed like a lot more concrete? Then that would again exacerbate the problem I'm talking about, where you would have less concrete at the apex. So I'm worried about this concrete pouring throughout. I can't emphasize that enough. I just have so many questions about it. I can't see any other way that it can be seen to be a permanent structure. It just doesn't have it just doesn't have the quality attached to it that I would require to see. This sequence of events where he coordinates and sets out where he wants the corner to this tunnel and where it leads into the house, it is genuinely impressive. It's hard not to feel, he's put in a lot of work, and it's hard not to admire him. This is hard. The task that he's taken on is difficult, and it's taken him years. And, that endeavour is admirable. I'm not denying that fact. All I'm saying is that at the beginning of the project, he should have appreciated that there are some things that you can do with sheer desire and determination, and there are some things where you're living in a bureaucratic universe and certain pieces of paper need to get signed, and you need to make sure that those pieces of paper get signed. 'Cause that's the mistake. Not involving the right people. It's a lack of hubris. It's a lack of understanding of the process that he's dealing with. And I'm not entirely sure with this whole secret tunnel idea. I'm not sure whether he approached it with genuine ignorance, i.e., he had no idea that this is how it actually worked, or whether it was negligence in that he knew exactly how it worked and he decided not to do it. But it's hard not to admire the dedication that it took to make this thing, even if it doesn't conform to the standards that it requires.
Okay, exciting bit. Roof supported, so we can start moving forwards again. Now this is the dig where we probably end up getting level with the house. So, are we going to see the house foundations, or are we going to end up going straight underneath them? All will be revealed very soon. So, do I want to see my house foundations when we're digging? Because there's a few things to consider and a few different ways we can look at this. Now, if we look at a cross-section of the tunnel, we've got this clay at the top here. That, of course, is not very hard. Then we've got this soft, looser stone, not too bad. And then we've got the rock-hard stone at the bottom, very good. Now, if we dig down and we see our house foundation either on the soft, loose stone or the rock-hard stone, then we know the house is on completely solid footings. It's not going anywhere. We can dig under it to our heart's content. Nothing's moving. That's all good. But of course, the downside, we'll have to chop a big arch out of the house foundations. That could potentially disturb, vibrate things, might cause, a bit of cracks and stuff inside. That's not so good. Now, of course, if it's up here somewhere, right up here, we've got less to chop out. That's good. If it's completely not here, we don't have to chop anything else. That's really good. But, of course, that means that the house is sat on something which is slightly softer, and therefore us digging under it is more likely to disturb it. But there is another thing to consider. In the winter, like it is now, there is more moisture in the ground, and that can cause the ground to swell up slightly, and the house can very slightly lift up, as you can see with my wonderful Lego and sponge demonstration. Now, of course, in the summer, when the water content goes down, the house can sink slightly. We're only talking, fractions of an amount here, but Colin goes and builds a tunnel off this hard stuff right up to his house foundations. I'm effectively putting something that's not moving on something that is moving, and then I could end up actually cracking the house over the tunnel. It's not so straightforward, is it, this tunneling malarkey? Right, back to me with a silly face, laughing because I'm digging under my house, not worrying about any of this.
A moment of pure clarity. He's got it. He understands it. Or he did, and then he immediately disregarded it. This is the point where it verges between ignorance and negligence, where you're doing something wrong and you just do it anyway. I mean, this is the ultimate. This is the problem. I mean, you dig a tunnel in your back garden. It's not going to get planning permission. Nobody cares. If it goes wrong, and as long as nobody's in it when it goes wrong, then nobody's going to care. It's just going to be a small cave in your garden. But you dig a tunnel under your house. You have the potential to render the value of that house as zero if you can't get someone to sign it off. You know, this is the only point where this matters. This is the point. You know, all of this tunnel stuff that I've been talking about is just me giving advice. This is the moment where it's genuinely worrying. I genuinely hope he's made enough money from all of these videos to justify the value of his house being zero, because that is the way that I see it, the way that he has made his house. You know, and if he had got an engineer, from day one, this is the first question they would have asked. They would have asked, what geology are we digging into? Where are the foundations to this house that we're digging under? And what is their relationship between them and this tunnel? Let's get that on a section. I want to see that on a section, because that is the only part of this tunnel that matters. You design this part of the tunnel and then you copy it everywhere else. So because that exercise hasn't been done, I'm going to do it, and we're going to go back to my sketchbook and we're going to do a section ourselves to see what this actually looks like. So, this is the section that I would have drawn first up before doing absolutely anything. So I would have dug a trial pit somewhere around the perimeter of the house to ascertain the level of the foundations. I mean, and I haven't put ground level on here, I suppose. Let's put ground level up there. I would have dug a trial pit to work out the depth of these foundations in relation to ground level. And then I would have got a borehole, someone to drill a hole and find out what the geology is like. And with those two pieces of information, I would have been able to draw this section exactly as I presented to you now. And the thing is, I'm relying on information that he is presenting and going to tell us later on in the video. But if he, you know, I'm relying on that foreshadowing knowledge. But ultimately, if we'd got an engineer involved from day one, this is the first thing they would have done. They would have understood straight away. Like, this is the... So anyway, this is the wall of the house. This is the foundation of the house. This foundation is 200 millimeters, 8 inches thick. Very, 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 very thin and relatively shallow. You know, I mean, it's probably about 800 to a meter deep. Something like that, which is reasonable. That's a good foundation for a building. You know, if I was looking at this building, Sands Tunnel, yeah, fine, absolutely hunky-dory, got no problems whatsoever. The problem is that you dug a tunnel under it. So now, the tunnel, they've got two scenarios. Either the tunnel has got to support the weight of the structure above it. That's scenario number one. So we designed this structure with reinforcement, and we work out all of the forces around it, and we give you a nice steel cage, reinforcing schedules, bending schedules, the lot, and you construct this cage, and then you construct this cage for the rest of the tunnel. That's option number one. Option number two would be to somehow bridge the gap. So we would have to potentially, in fact, this is probably where you would need to go now, having to retrofit these things. If you were looking for a solution of how to do this, I would have done it the first thing. You have to underpin the main building. So you want to create a new foundation which brings this foundation beneath this one. So we would underpin this side, we would underpin this side, and then on those two new foundations, we would put in a big steel beam, potentially galvanized, potentially encased in concrete, and that would support the house over this gap where the tunnel is. But I don't know whether that's possible now that the tunnel is in place, because by trying to dig this underpinning, you're going to completely undermine the house. You know, when you dig this part of the concrete to underpin and this part, the house has now got a span from here all the way over to here. It's like double the distance. So if you were doing this from scratch, you would underpin the house first, you'd put this steel beam in, and then you would construct the tunnel in it, and the tunnel would be sacrificial. No one would care. But now that it's there... Anyway, let's carry on with the video. There's more to see.
Okay, right, got a plan. So, we dug down, found the concrete foundations under here, so we've got a measurement now as to how deep the whole thing is. We've actually drilled a hole through the concrete foundations. We know that they're about 8 inches, 200mm thick, which is not particularly thick. So we know that in our tunnel, we're actually very close to them. There's not much dirt above us underneath them. We're going to try and keep that there. We've dug a hole up, and we've now exposed the house foundations. This is the bottom of my house.
Let me just refer back to what I was just talking about with threading this new... If we were trying to fix this situation, we were trying to thread a steel beam in to support these foundations in at some point in the future, which is where we are now after he's done all this work, we would have to thread it beneath the bottom of these foundations and the top of his tunnel. And that looks like about 100, 120 mil, 150 mil maybe maximum. And you know, the kind of size beam that you're probably looking at is 250 mil, you know, 10 inches deep. It's not going to fit in there. And then we would have to potentially encase it in concrete. And that's going to be make it thicker. You know, you're actually going to have to either remove the foundations, which, you know, that's a real sketchy thing to do whilst it's not being supported, or try and cut the top of your tunnel out in order to get this beam in place. It's completely impossible. It's completely impossible, the idea of doing this. And again, if we knew with forethought that this was the situation we were going to end up in, we'd just dig the tunnel 6-8 inches deeper than he has done, so that we had that space. You know, it's just the lack of kind of forethought and planning. It's really kind of forced him into a corner.
Foundation, we've dug a little bit more of a hole. We think we're about 2 or 3 inches away from the hole in the bottom of the pantry. Right, let's get in the house. Ready for a nice steel inner tunnel to be covered in concrete. But there's a few things we need to consider. We come up the ladder. So basically we've got our brick foundations, engineering bit, and then obviously the...
Look at all that weight. And I'm not just referring to the weight of the masonry either. I'm imagining that we've got floor above it, we've got a roof above it. All of that weight, and it's being supported on absolutely nothing. Oh, it's just a scary moment watching this. Really scary.
Start getting a bit of the steel in. We've got the floor down. Very nice, Colin. Now you may notice up here, what is all this? Expanding foam. Well, there was a tiny little bit of a gap where the cement like come down underneath the house foundations. There was a little bit of like a 1 inch or 2 inch gap at one point where it didn't quite rise up and meet the clay, which is obviously not very good. Now we did experiment. We're trying to pump concrete down there with our little air-powered concreting pump device, but all we did is just spray it everywhere and get a complete mess. So instead, we've chucked a load of expanding foam down there, which is not my favourite material ever, but it's better than having nothing and having a little bit of a void. So
I am gobsmacked that you included this bit in the video. Absolutely gobsmacked. I mean, the only part of the tunnel where you wanted a good contact between the tunnel and whatever was above it was the part where you're under the foundations, and you failed to close that gap. And you've chosen to fill that gap with expanding foam. I mean, you've got this note on the bottom, the only time this was needed, thankfully. Yeah, well, okay, so number one, it's the most important part. It was the most important part for you to get right. It was the only part where you really needed to use it to get it right, and you should not, absolutely have not been using expanding foam. So number two is you're asking me to believe you. I mean, we go back to that, what I was saying earlier about being, you know, about this course of action being untrustworthy, and now you're asking me to believe that this statement was, that this was the only time that you needed to do some sort of remedial effort to patch up poor concreting. I can't believe it. You know what? Even if you aren't aware of all of the problems, Mr. Furze, even if there are problems that exist that you aren't aware of, I am certain that they exist, whether you know about them or not. The only time this was needed, well, in this situation, it's the only time it mattered on this whole job. But it raises questions for the project as a whole.
All good, all set, all gone off. Now then, the main question, the big one, the one that is absolutely through all the comments in all of the previous 8 videos, and the reason why this video has been a little bit late in coming, is how on earth, Colin, did you get permission to do all this? From the council, the authorities, the state, the city, the building permit people, whatever country you're in, obviously it's all got a different name. Well, let me tell you. Now, the short and simple answer is I didn't have permission for it. Not until a week ago, anyway. I didn't feel like I could make this video, which is why it's so late, until I actually knew the outcome of the planning application. But, you know, I'm pleased to say it got planning permission. It's all good. I don't have to fill it in. Now, basically, it wasn't I wasn't going to tell them. It's just that I always think it's a bit easier to ask for forgiveness of what it is for permission. And also, obviously, we've put in planning permission before. You essentially just give everyone else a head start to moan or worry about it. I didn't want anybody to do that. So I thought, you know, let's just crack on with it. So up until the first video landed, it generally was a completely secret tunnel. Only a handful of people knew about it. Now, the council were actually really good. It wasn't, I think, till about video 5 that somebody at the council saw it on Facebook and rang me up. But they sent a guy out. He was a really nice bloke. He come around and had a look at it. You know, he was quite impressed with it. He wouldn't let me film it, unfortunately. So you'll just have to imagine what a council worker is like coming round to inspect a secret tunnel. Wow. 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 But anyway, basically one of the other reasons why I didn't apply for it is because they always want like detailed drawings. When I did the bunker, I remember applying for it myself, and my drawings, you know, like the one that you see at the beginning of all the other videos, is not good enough. Has to be scale, has to be done properly. Now with the tunnel, I could have got some of those done, speculating on what it might be like, but having not really known how deep I was going to go, the directions and everything, I thought, we'll do it afterwards. It'd be a lot easier. So, basically got these drawings made up.
A genuine, bona fide drawing. Finally. Finally. Jeez, it's taken so long. Right, I mean, let's be frank. This isn't a proper drawing. It's just a hand markup. So I'm imagining that this is a drawing that was produced when he did his bunker in the back garden, and they did a fully surveyed drawing where they did a proper planning permission, proper process. And then Colin Firth has taken that drawing to an architect and said, I need to get planning permission for a tunnel. And in an hour or two, the architect has scribbled on those existing plans and submitted them. Now, these are not detailed drawings. These are not the sort of drawings that you would build to. And I am genuinely surprised that they got planning permission, because there's no spec here. It's just dashed and dotted lines on a page. Let's carry on, because there's more to see.
These are pretty cool, really. Shows here, look, here's the house, and then this cross-hatch bit section here is where obviously the tunnel goes. And then this little chevron, well, just lined bits here, that wasn't there when the guy come up, but obviously that's just a straight bit of tunnel, so, you know, I said to him, you can work that out pretty much yourself. So, but these are pretty cool. I'm quite pleased with these. I actually might make a poster out of them. So we've got this one, which shows where it is in correspondence with the shed and the house. Then there's this one, which is just a tunnel on its own.
Okay, so this is a little bit more detailed. This is a little bit more care and effort has been put into this one. There's not much to say, really. This is just a plan showing the layout of the concrete walls. It's not an engineering drawing. This is just what the architect has put together. And it's what you would classify as an as-built. It's what's been built. It's not a planned design. It's this is what has been built design. And you'll notice that the walls change thickness. One part of the walls are 150 and another part of the walls are 300. So he started on the left side of the map and we worked his way to the right. He started off with just walls that were only 150 mil thick, and then he moved up to 300. Now he kind of squeezes out of this one by saying that it was a suggestion from someone in the comments, and B, that it was a result of building closer to the house. But if you look, then the house is still close to the rest of the tunnel. Like, if I'm an engineer and I go along and I say, well, if you needed 300 thick walls here, why didn't you need 300 thick walls everywhere? What's the answer to that question? Because I don't know the answer to it. And I can tell you for a certain, if he's built 150 mil walls there and he was aiming for 150 mil thickness at the apex of the tunnel, then we've probably got no concrete up there at all. Now, the 300 thick walls is in the right ballpark if it was reinforced and properly waterproof and tanked. But other than that, this doesn't show anything else. It just shows the basic layout and the basic thickness of the walls, which I would question anyway.
The thicknesses and everything, and obviously this displays the fact that the concrete got a lot thicker as we got nearer to the house, because don't want the house subsiding, do we? So that's all good, quite like that. And then we've got this one, which is like a cross section, which shows all the bits, got the allow code for the pumping.
And now some sections. I mean, not the section that I would have drawn, because I'm an engineer and I look at these things differently. This is an architect's section, so this is just displaying the basic sizes of things. And architects are mainly concerned with dimensions and insulation and waterproofing. They're not really concerned with the structure itself. So when they see a structural wall, they just draw a structural wall and they don't really care about what it's made of, what's in it. They just draw it. And the important section here is section BB. This shows where the foundation is sat directly on top of our tunnel, and it does kind of indicate a small thickening to the edge of the roof of the tunnel. I'll put a little box around it so you can see it. Now this is probably what would be required if it was done correctly. If it was reinforced and it was done right, then that's probably the right way to go. But it's been drawn, and I'm not confident that that is what has been built, because that's exactly where he put this expanding foam. That's not on the drawing. Anyway, let's carry on.
Bit up to the shed, bit up to the house and whatnot, the ladders and stuff. How cool's that? So there we are. That bit of a gamble paid off. It's all good. Sailed straight through.
There is a core misconception here, and I'm not entirely sure, again, whether Mr. Colin Firth is aware of this and he's portraying it as the way that he's portraying it because he isn't aware, or whether he is aware and he's just telling a story. So I'm going to tell you what the situation is, and you can judge for yourselves. So when you go and get planning permission, the council says, yes, you can build this thing, and that's the start of the process. Then you could build the thing, and the council and the engineer and all the relevant people check that you're doing the work, if necessary, as and when they want to. And then at the end of the building process, you get building approval. And it's that building approval that makes the thing that you made have value. If you only have planning permission for something but not building approval for it, then it's not a thing. It's just a made up thing. Let's just assume if you had a house and you had planning permission for a garage, a new garage, and you were selling that house, then you would sell that planning permission in addition to the house. But if you had built that garage without planning permission, then you would need to retrospectively go and get it, and no one's going to buy the house without that garage having planning permission. I mean, garage is probably the wrong. If it was like a side extension or a granny annex or something, people are going to care about that. They're not going to buy your house if you've got that on your property and it's not got planning permission. And this is exactly the same. This is where Colin Firth finds himself. He's got permission to dig a tunnel, but he hasn't got the approvals necessary to sell that tunnel, and that's why it has no value. And if he'd just been a tunnel in his back garden, then it wouldn't matter that it had no value, because it could cave in, just like I said. As long as there was no one in it when it caved in, when it collapsed, it wouldn't matter. It would just be sold as an addendum. And if the person who was buying the house was willing to pay a premium for that tunnel, even though it didn't have permissions, then they would be open to doing that. But when you dig the tunnel under the house, it becomes a whole different matter. And the lawyers get involved because you don't have the right paperwork and you've done something sketchy, and the lawyers go to an engineer and the engineer says, oh, I'm not putting my name to that, and then they start scrabbling around trying to find an engineer who will, and then at some point they walk away and you're left with a building that's completely unsellable. So, planning permission is one thing, building approval is completely different, and that is the stage that Colin Firth hasn't done yet. Now, I've done some background research on where exactly this application stands, and where it stands at the moment is that Mr. Firth is obligated to find an engineer who will put his name to that tunnel. That's the next stage. And once he's got that engineer on board, the engineer will do some work, do some things, potentially suggest some ways to remediate the situation, make it better, and then eventually that engineer will give Mr. Colin Firth his approval. And then that approval will go to the council. They'll rubber stamp it. Bingo, bango, bongo. You've got a house that's actually sellable again. But as I've tried to demonstrate through this video, I'm not sure that's a straightforward process. I'm heavily sceptical that there are going to be any engineers out there who are going to be willing to take this project on and put it on their insurance. Because here's the thing. If I put this project on my insurance and it collapsed tomorrow, I would be responsible for it. I would be taking ownership of all of the mistakes, all of the decisions that Mr. Colin Firth has made on this journey. I would be taking complete ownership of it. And you know what? If that house did collapse, subsequent to me giving it my approval, Mr. Colin Firth could take me to court and sue me. So there's not going to be any engineers that stand by this, because it gives Mr. Colin Firth carte blanche to deny any responsibility for it. You know, the engineer would be assuming that responsibility away from him. And I'm very, very sceptical that situation is ever going to come about. Very sceptical. So with planning permission granted, this is the end of the series of videos from Colin Firth. This is kind of where he ended it. This is the end of the story that he was telling. It is absolutely not the end of the journey. He's obviously still got to go and find an engineer who's going to stand by this, if he has any intention of that house having value or selling it at any point. And then, as I've seen very recently, the tunnelling doesn't stop either. The tunnelling continues. So there's probably more to go, but for this video, that's it. I hope it's been interesting. It's been a long watch. Till next time.